Hello, good evening. Good evening, all of you. And please let me know if I am audible perfectly. Dear participant, can you please let me know if I am audible? Yes, you can either reply me in chat box or also you can unmute. Can you please confirm me? I am audible?
Yes, you are audible.
Okay, thank you. So this session was organized for the last week, and due to technical issues, I was not able to deliver this session. This is special session was organized for how we can use Python for symbolic mathematics. So we will discuss here, and this is just a demonstration to use Python software, which is open source, and we can use for symbolic mathematics, different type of problems we can use, like mathematical modeling, polynomials, calculus, matrices, geometry, plotting, physics, statistical problems, and combinatorics. So in various ways we can use, and along with the, as we know that machine learning, deep learning, data science, etc. This Python is very helpful for AI. And in the case of AI, many mathematical formulas are there. So if anyone wanted to switch in AI or machine learning, deep learning, so this is also very helpful tool, and we can start very easily. And along with the, we can use machine learning to find out the solutions of different type of problems which are involving like differential equations, numerical methods, automation techniques, and many more. So how we can use, I would like to check, there are some participant might be participant on live streaming. Okay, so just 1 minute. I would like to share first my desktop, and then we discuss all this. This is my desktop. So for using Python, this is Anaconda Navigator. And you can easily download by searching this Anaconda Navigator from Google. And if you want to see, you can easily download from this place. I'll let you know, please. Just search here Anaconda. And from the Google, from the very first link, you can download, click this link. This will be open, and from this place you can easily download Anaconda distribution. And when you will install, and after when you will open, installation is very quite simple. And when you will open, this will appear like in this way. So there are various type of this is the home page of the Anaconda Navigator, and at this place there are different type of libraries you can see, and all these are used for different purpose. You can see Jupyter Lab, and Jupyter Notebook. Then we have RStudio is also there, PyCharm, Orange, Glueways, Spider, Qt console, and all these are used for different type of purpose. As you can see at this place, we have Spider, a scientific Python development environment, and powerful Python IDE with the advanced editing, interactive testing, debugging, and introspection features. And if you want to use Glueways, why this Glueways is used for multi-dimensional data visualization across file, export relationship within and among related data sets. Similarly, there is Jupyter Lab, which is an extensible environment for interactive and reproducible computing based on the Jupyter Notebook and architecture. So all these are for different purpose, but we right now target Spider and for the purpose of symbolic mathematics. So when you will click at this place, Spider will launch, and after launch, this will a new window will open. Okay, and it will take some few minutes, and it will be launched. Yes, so this is the window of Spider, and in this you can see easily there are several partitions. Okay, so this is the console of the Spider. At this place we can execute the sequence of statements, and on the left hand side you can see when you will open, this will appear like in this way. At this place you can write your script file, and you can use for some different type of programs as we can use in the Matlab. In the same way, you can write your own program at this place, and you can save it and use for different purpose. And this is the console, and at this place you can say all the files which are spotting or we have saved in the drive, you can check, and then if you plot for any outcome or for any function, you can see at the plots and variable explore, and if you need any help, you can use this part also. So this is the very small introduction about Spider. Okay, along with I would like to open one more window. See, along with at this place, you need to open, go to live.sympy, live.sympy.org. So when you will open, you can see this is the livesympy.org, and at this place, this is the main library which is used for symbolic mathematics, and this will be very helpful for all of you who are attending this session. At this place, actually, there are different libraries for Python, and we can easily import in the Python, and then we can use. So when you will open SymPy, this is the small partition at this place, and I need to increase the size so that yes, okay, now it is fine. So we discussed two things. One is this is SymPy which is online, and also this is SymPy we can use in Python. Okay, by using the Anaconda. So just 1 minute. This is the Spider. This is the Spider window. Okay, and this is port Python. So you have these two things. One is SymPy library which you can use online, and all the commands which we will use at this place, we can execute all these statements on Spider. So we discuss all these one by one and how we can use there. Okay. Yes. See at this place, when you will open, see these statements. So what is SymPy? So SymPy is a Python library for performing symbolic computation. It is a computer algebra system that can be used either as a standard alone application, is a library to another application. And this is the live version of the SymPy, which is available here. Since it is a pure Python library and it can be used as interactive mode and as a programmatic application, SymPy has now become a popular symbolic library for the scientific Python ecosystem. SymPy has a wide range of features, applications in the field of basic symbolic arithmetic, calculus, and algebra, discrete mathematics, quantum physics, etc. SymPy is capable of formatting the results in a variety of formatting, indexing, LaTeX, and MathML, etc. SymPy is distributed under the BSD license, which is free available. And this library we can use for polynomials, calculus, discrete mathematics, matrices, geometry, plotting, physics, statics, combinatorics, etc. Okay, so here we will discuss how we can use. So just 1 minute. Okay. You can go at the documentation. This is the documentation which is online, and at this place, this is the introduction about SymPy documentation, how to guide explanation SymPy. The most part at this place is SymPy tutorial. So when you will open SymPy tutorial, at this place you can see all this about SymPy, and this will be very helpful because in 2 hours I will explain all this, and you can easily use this SymPy on. Also you can use it on your mobile. It will open, just you need to use, I will provide you the link, and by using that particular link you can open it on your mobile also, and you can open on your desktop. So at this place you can see contents. See these content. Okay, so in this content, how you can install exercise, introduction about the symbolic computation. You can easily find at this place installation, and some codes are there. You can find if you want to use in Python, then how we can use. So you can see at this place, these are the codes, and by using this code, you can easily use in Python. So if we want to declare the symbolic variable on the right hand side, you can say symbolic variable. Yes. Just 1 minute. So here you can see these are the symbolic variables are declared, and there are different ways to use symbolic variable. Either you can declare from SymPy, import this one, product sign, then we have X, Y, Z, T. So we are choosing here 4 variables, and we want to use as a symbolic. So we are using here a symbols function. This function will be used, and we are declare at this place that x, y, z, t are symbolic variables. Or the another way you can see at this place, if you want to declare that k, m, n, these are integers, we can declare in this way, k, m, n, these are integer, and make it true, is equal to true. F, G, H symbols, and these symbols are functions. CLS is equal to function. So this is the way to declare all the variables for integer, for function, and it is very quite simple to declare. Again, yes. So all these, you can see all these are very quite codes which you can run online also. First you need to import math, and then math.sqrt. Okay, see in the spider also. Sorry, this is the spider, and you can see all these. So at this place, first what you need to import math. Import SymPy and import math. Okay, so this is very quite simple. I would like to increase the font size so that yes, if you need to increase the font size, just press Control Shift and enter press. You need to press 3 keys. One is Control Shift and plus sign. The size will be increased, and if you want to decrease, then Control and minus. This will be the font size will be decrease, and if you want to increase, then Control plus sign. So the font size will be increased. Okay. Now how we can use? See, if we wanted to take square root, so the command is very simple, sqrt, and suppose that we are taking the square root for 7, and when you will enter, okay, Control L, we need to import, yes, import math, and then print and this is the math library, and from that we are using the function. We can use in this way, math.sqrt and 25. So when you will enter, we have the square root of 25. Or either you can directly use like math.sqrt 25 and then enter. So you have it's a square root of 25. Okay, and also if you want to evaluate from SymPy, import SymPy. If you will import SymPy, and then if you will like to use the same statement which we used in the above, see math.sqrt 25, and when you will enter, it return the outcome. But if you have math.sqrt and you have 7, and when you will enter, we have the square root of the same. And also this is the math library, and if you are using sim function, sympy, then see sympy dot sqrt. If you are using here 25, then the outcome is there, but we have to use this statement like in this way. Print command we have to use to print the value, because now 25 is a symbolic variable and it will return the value after simplifying. In the case of mathematics, it return directly after calculate. Okay, so here we have to use the print command. See, here we are using sympy.sqrt to find out the square root of 25, and when we will enter, we have this outcome. Okay, but if we are using print command also, this will return the value in the console. So at this place, you are using math.sqrt. Math, we are using the functions which are related to mathematics. Okay, so it will return the value directly. There is very little difference to use these statements. If you want to square root, then we have to use dot sign with the math. And in the same way, here is only symbolic variable, but we are using sympy.sqrt. So this will return the value in symbolic form. And we have to use the print command. Only then this will return the value in the console. If you are using, say, if we have 2, 7, we have only 7. See what happened. Here, 7 is symbolic and it did not calculate the value. It returned the value in the form of symbolic. And if you are using like in this way, math.sqrt 7, okay, it will return the value after simplifying. So this is the main difference between when we are using symbolic, because at this place 7 is converted into symbolic, so it will return as it is. We don't have any perfect square root of 7. So symbolic functions are used to simplify the functions which are involving. See some more examples related to this one. We are from sympy import this. So what is the in the symbolic sympy library, sympy means symbolic Python. Okay, and in this library there are all the functions are available, and when you will import this product sign, it will import all the functions which are used for mathematically. Okay, and then enter. Now we declaring the variable x is equal to symbol. This is the symbol. We can declare here x is a variable. Okay, and then enter. Now we can use this x variable for integration, for differentiation, or for to solving the polynomials which is involving x variable. See expression, we have the expression which is equal to we want to integrate. So in the Python, we have the function integrate to integrate any function. Suppose we have x and x. What is the meaning of x double dot product x? So the meaning of this is x exponent x. Okay. The meaning of this one is exponent of x. And we want to integrate this function with respect to x. And when you will enter, what is the meaning of this one? The meaning of this one is integration of x raised to power x function with respect to x. Okay, so see here EXPR, and when you will enter, so you can see at this place, you can see this is the integration x raised to power x dx, or you can print like, sorry, if you are using print command and see the expression EXPR and enter. Okay, so here there is no outcome, but at this place you can see this is the integration x raised to power x dx, but here x is symbolic variable and it did not simplify. But if you have the function like f is equal to, you want to integrate sine x, we have sine x, this is the trigonometric function, and enter. If you want to integrate f with respect to x, and when you will enter, so you can see this is the integration of f function, which is sine x, and the value is minus cosine x, or you can use the same like by using the print command, See, the integration of f function, which is sine x, and here we are using the integration. Okay, and also along with when we will use the print command, this will integrate the function f with respect to x, and this is the outcome. This is the output of this function, and that has been printed at this place, minus cosine x. If you have, you can also use the same like in this way, print and integrate. Then we have a function like we have sine x, plus we have x cube, double product sign represent for exponent. So this expression is, the meaning of this expression is x cube. Okay, and we want to integrate this function with x, and when you will print this command, you can see, sorry, sine x. Okay, there is small mistake in the writing here, x is extra. Okay, so when you will enter this statement, you can see this is the integration of this function. The integration of this function is x raised to power 4 upon 4 minus cosine x. This is the integration of this function. Okay, and is it okay? If you have doubt all this discussion, please you can unmute and ask from me. If you have question, please feel free to ask from me. Is it okay? Please let me know. Is it okay? Yes, anyone?
Yeah, it's okay, bro.
Okay, thank you. And if you want to differentiate, then how you can do? So there is very simple command. All the commands which we are using in Matlab, we can use also at this place. It's very quite simple. So here is DIFF, and suppose that we have a function sin x. Okay, this is the sin x, and we want to differentiate with x. And when you will enter, this is the cosine derivative. You can see, but this is not readable at this place. Okay, no problem. You can print this statement like in this way, DIFF, and we want to differentiate sin x. We want to differentiate sin x with x. And when you will enter, you can see the derivative of sin x is cosine x. So here we can easily write any function. F is equal to, we have sin x, then we have product, x square. Okay, this is x square. Then we have plus, we have exponential function is there. Exp is for exponential function, and product x. Okay, we have this function, and the most important thing is that we can easily write any function and we can use anywhere. So now print, we want to integrate f function with x. Okay, and also comma differentiate f function with x. Okay, here we are checking the derivative and integration of f function with respect to x. So you can see we have both the results are there at this place. The first expression is the integration, which is from, yes, this is the first one, and then this is the second. So we have both the results are here at this place. First expression is for integration, and second part is differentiation. So easily we can use this symbolic variable for symbolic calculations. Now, Control L. Control L is used for clear the desktop. From SymPy, import float, F-L-O-A-T, float. So all the functions are available in SymPy, and whatever we need, we can import. So when you will import this float function, and you can easily use like F-L-O-A-T, how we can use float This is, suppose we have any floating number 6.32, and when you will enter, we have to use the print command also. Use print and float 6.32. See, so this is the float. Also, if we use float for 10, see, print float and 10. See what happened. So this float function will convert number, any integer, in floating number, and we can use for our purpose. And also sometimes we need to customize. You can do also for customize. Sometimes you need 2 decimal, 3 decimal, 4 decimal. How we can customize? See, print, then we have a float, float, and we have the number 1.3333. Okay, and we need only 2 decimal. So if you need 2 decimal places, then use comma. 2, it will return 2 decimal places. See, so this is only 1.3. And if you are choosing here 3, so it will return only 3 digit. This will return only 3 digit. Okay, so in this way we can easily use this float function to customize. Okay, and just 1 minute. Also, there are some functions like you can use S, import S, and this is very helpful. S.0 attribute not installed in SymPy. Okay, from SymPy import S and S.0. S.0. Okay, so there is S variable, and from this place we can easily convert. So S.0 will return 0, or either you can use like in this way, S.0. So this will return 0. And if you will use S.1, print S.1, this will print 1. Sorry, P is small. P is small. So it is returning 1. And if you are using S.half, print S.half. Okay, here is half, HALF. And when you will enter, it will return 1/2. Okay, and if you are using nan, what do you mean by nan? This is nan, not a number. Okay, so it will return nan. And if you want, you can use also infinity. Okay, from SymPy, import This sign is used for infinity. Okay. Or print s dot infinity, s dot infinity, and when you will enter, you can see infinity is there. So these are very small different uses. Now we discuss here yes, control L. Now we discuss about the some symbolic variables. Okay, so from SymPy, import symbol. Okay, as I have shown that import symbol. So this will import the symbolic variables, and then we can manipulate all these. See, either if you want to declare x as a symbolic variable, then this will be declared as x is equal to symbol and x, then close the bracket. This is the x variable. Similarly, you can use a y variable. Is we have to declare before use. Okay, this is y. Also, if you want to declare more than two variable, you can do easily. See here we have the expression. We have the expression. Expression is equal to x. What is the meaning of this one? The meaning of this one is x square plus y square. Okay, x square plus y square, and print axpr. And when you will print, this will return the same value because these are x square plus y cube. Okay, these are symbolic, so it will return in the same form. See, if we have f is equal to, we have a function f is equal to sine xy. Okay, sine xy. This is xy plus we have x cube and product exp. Here is y. So this is a function of two variable. We express here, we write here function of two variable involving x and y. Two variables are there. If we want to take partial derivative, or we want to differentiate partially either with respect to x or with respect to y, how we can do? This is very quite simple. DIF, differentiate the function f with respect to x. Okay, so if you will differentiate this function with respect to x, y will be constant. See, when we will enter, so this is the derivative of f function with respect to x, or print the function. Use the print function. We are using here DIFF and f comma x. See, so this is the partial derivative of this function with respect to x. And if you want to differentiate, f function with respect to y, f function with respect to y, then this one. So this will return the derivative of f with respect to y. Print. See here. Okay. So this is the partial derivative of f with respect to y. If you need partial derivative of f with respect to x 2 times, okay, see di, we have this function and f is a function, and x comma x. What is the meaning of x comma x? This will differentiate f function 2 times with respect to x. Okay, and also we are using here print function. This will print the function, and see, and when you will enter, this is the output. If you are using the statement like in this way, so you can see here is differentiation of f with respect to x, then with respect to y. So this is the second order derivative of f with respect to x as well as with respect to y. So this is a partially derivative of the second order, and with respect to x and with respect to y. We can use this statement for the partial derivative, which is mixed partial derivative with respect to x and with respect to y. See, this is the output. Okay. Similarly, if you want to integrate the same function with respect to either x or with respect to either y, we can easily use the same. Please let me know everything is fine. Is it okay?
Yes, yeah, everything is fine.
Okay. So for integration, we are using print. Then we have integrate f comma y. So this will integrate f with respect to y, because f function is function of two variable, one is x and other is y. So when you will enter, we have this is the integration outcome of the above function. Sometimes by using Control L, okay, but desktop will be clear. Also, you can declare multiple variable in the single statement by using from SymPy import symbols okay. You can declare the variables like x comma y comma z is equal to symbols then x comma y comma z. By using this single statement, you can choose, you can declare the symbolic variables, and then you can easily use for different purpose. So there is one more module for the to declare the variables, that is from SymPy .abc. ABC is also used to declare the variables. Okay, import x comma y comma z. Okay, you can also declare the variables by using this. Either you can use this statement, either you can use this statement, or you can declare one by one. Okay, so this is the some basic use. After that, yes, Control L from SymPy. SymPy is library which we are using in Python, and all the manipulation we need to import from SymPy only. From SymPy.abc import x comma a. Okay, and we have the expression AXPR is equal to one is sin x product. We have again this is sin x, and then we have plus cosine x and cosine x. So this is the statement sine square x plus cosine square x. Okay, and when you will enter EXPR, you can see at this place this is sine square x plus cosine square x. But if you will print and by using this statement, this will return in the form of symbolic form. Okay, see, sine square x plus cosine square x. Okay, this statement is reduced into this one. What is the meaning of this one? This is sine square x plus cosine square x. Okay, we can use a substitute function. If you have a function and you want to substitute values, you can do easily. See, this is the function, and then subs. This is the substitute function, and when you will put at the place of x, we are using a. Okay, so we are substituting the value for x equal to a. When you will enter, sorry, subs. Okay, there is small error to use. Here is subs, and when you will enter, see, we have at this place, this is sine x square plus cosine x square, and that is now we have, you can see this is sine square a plus cosine square a, or either you can use print command. Okay, you can use print command, print, and see what happened. Yes, so in the above we have you can see at this place, this is the equation with the x variable, and here you can see at the place of x we have a. So by using this subs function, we can substitute the value. Okay, so first we have to write the function. We have expression dot subs. So first will be function, and then we will use a subs function, and this is the x variable, and at the place x we are using a. Okay, or either see, if I am choosing replacing here 1 0, so what happened, you can see. So this is the symbolic, the values are returning in the form of a symbolic, because x and a are symbolic, and symbolic variable is are imported here. So you can see at the place of x we have 10. So in this way we can easily use a subs function. And if you are using, see here, if we put at this place pi, this is pi, and then enter, you can see this is equal to 1. Okay, we know sine pi is 0. Sine pi, this is a sine square and this is cosine square. And sine pi is 0 and cosine pi is -1, but we have square, so it is 1. Okay. Is it clear? There is one more function which is we can use. See here, control L. There is evaluate function. Okay, from SymPy dot abc import R. Okay, and expression is equal to, this is pi, then product, this is pi, product, R square. This is R square. So this is the formula for pi R square is formula for the area of circle. Okay, and when we enter, sorry, this is symbolic EXPR is equal to, you can see this is pi R square. Okay, I think I have to increase the size. See this value. This is pi R square. Okay. So in another way, you can write like print by using print. EXPR. Okay, this is the function. This is pi R square, the formula for, and area of the circle. Okay. Now we can, this is a very simple function, and we can evaluate the area by using different values of R. See, expression dot EVALF. Okay, this is the evaluate function in the Matlab, in symbolic SymPy, which we will use for evaluate the function eval f. Okay, and here is subs. Here is subs equal to R5 and then enter. So you can see this is the area when we have radius is 5, and you can see this is the returning value, or either you can use the statement print also. Print, print, print. See, this is the value. So there are several use of this SymPy. Now you must come to address place. Yeah, you can see this is a live, and you can easily use this live version. Okay, so here is interesting examples. You can see all these statements which you can see at space easily execute in Spider. So these are very quite simple for integration. All these statements are given in the block wise, which we discuss here. All the commands are appeared at its place. Okay. So the power of a symbolic computation, you can see at its place. These are the symbolic variable. Then for initial code you can use also. This is the derivative, and for the integration, different examples are there. Yeah, also if you need to integrate to finite integration, you can also apply the finite integration. Yes, see this block. See this block. Increase the font size. Yes, yes, yes. All these are very quite simple. See. Okay. If you want to integrate this function, and this is indefinite. Okay. And also, if you want to compute this statement, see, my integration minus infinity to infinity sine x squared dx. So this is very quite simple, because here is the limit, lower limit and upper limit. You can express like in this statement, integrate sine x squared. Then we have x lower limit and upper limit. Infinity is denoted by minus in this way. This is the O key. Okay. So 2 times you have to write this statement, and also you can use the statement in spider. See, import SymPy, import Mat. Okay, this is the link only. This is the statement. Copy from this place. Copy from this place and come here. Yeah. And when you will integrate, see, this is the solution. Here is the solution after integrating this value. Or either you can use also the print command. You can use the print command. Here is print command, and when you will enter, this is the value of this integration. Okay, so in this way you can easily use for definite integral. So all the statements which you can see here, easily we can use. Okay. So also if you want to find out the limit function is there. See, here is, we want to find out the limit for sine x upon x is x equals to 0. So this is the syntax which we will use to find out the limit of any function. Sine x upon x and x comma 0. X comma 0 means x approaches to 0. So this is the limiting function. And when you will execute this statement, this one is its output. Similarly, if you want to solve any equation, like x square minus 1 is minus 2 is equal to 0. This is the equation, x square minus 2 is equal to 0, and you want to solve. So there is a solve function. And you can use, okay, you can use this statement. See, at this place, we are using solve, and equation is x square, and we have minus x square minus 2. Okay, x square minus 2, and we want to solve this equation for x. And when you will enter, you can see these are the root of the equation, minus square root of 2, and other is square root of 2. Okay, there will be 2 roots. So solve function can be used to solve any polynomial or any equation. Also, we can use dsolve function to solve the differential equation. If you want to solve, this is the differential equation, you can see At this place, you can see this is the differential equation of a second order y double dash minus y is equal to e raised to power t. And we want to solve. This is very quite simple to solve this equation. Just you need to write this is the first statement, y is equal to function y, and d solve function is there. D solve function is there, and which is equation yt dot differentiate differentiate tt. This will differentiate the expression two times. We are using here two times t comma t. This y double dash can be written as, just 1 minute. Okay. Just 1 minute. I would like to show you. Yeah. Just 1 minute. What is the problem? Okay. Control L. Set. So we have okay. So right here, import SymPy. Just 1 minute. What happened? Okay. And we were discussing here solver, matrices, calculus. Yes, this is the calculus. Okay. So partial derivative has been discussed already. So these are the examples for the derivatives which you can see and you can use. Yes, it is fine now. Okay, you can use online also. This is the statement, and it will take some time because it depends upon the network. This is the online, and you can use here any statement. Suppose x is equal to, we have sine x, sorry, this is f is equal to sine x. And sine and differentiate f with respect to x, f with respect to x. Yes. So you can use all these statements online on your mobile or on your desktop. How you can use? See, when you will open docs.simplify.org, and this is the small window. Whenever you will click on this, small window will open, and at this place you can see at the end, go to SymPy live. Okay, or you can use this statement, this live.sympy.org. So at this place you can execute all the statements which we have discussed from this place. Yeah, so all these statements which you can see easily execute in this part, live.sympy, and all these are very helpful. And also you can log in at this place, and after logging you can use your email address and allow it. So when this will permit you to save your work for your in the name of your email address. Okay, so at this place you can see the documentation, and this documentation will help you for any code which you need to see. All the details are here. All the explanations are there, and examples SymPy tutorial is there. SymPy. So all the examples you can see here, and you can take any topic. Matrices, this is the matrices, how we can write the matrices in Python. Okay, so you can see this is 1 minus 1 3 4 0 2. This is a matrix, and this matrix command you can see at the bottom. This is the statement, and matrix, the first square bracket represent first row, then comma 3 4 comma 0 2. So this is the expression for this above matrix, and all the element will be separated for first row or second row by using single comma. And you can easily find out numerous examples at this place. Determinant, for determinant we have m.d. First you have to write this matrix, and then m is equal to this matrix. Okay, and if you want to find out determinant, then you will use this statement m.determinant. Okay, so there are various examples here, and this is just overview about the SymPy, and I hope all these references which we discuss here will be very helpful for all of you. If you need to find out the eigenvalues, diagonal matrix, many more, all the things are here. You can find out. Details are available here. M is equal to this is the matrix, and if you need to find out the eigenvalues, then you need to use this statement m dot eigenvalues. Okay, and this will return the eigenvalues. Zero testing, and okay. So this is the overview about the SymPy, and if you need you want to ask any question, please feel free to ask from me. The statements which we are using SymPy live, you can use all these statements in using Spider. Okay, there is no difference in the use of these statements, and at this place you can see there are different solvers to solve the equation, to solve the differential equations. Okay, Sometimes we need to solve a system of equations also. You can find out here a different type of solvers are there in line. You can see this is the line solve, like x plus y plus z minus 1. This is the first, then we have second, and you can solve all these. So all the things in 2 hours is not sufficient time, but all the examples are here. You need to just understand the syntax of SymPy, and then you can use for their different type of task. Now I would like to ask from you, if you have any question, please feel free to ask from me. Yes, please, any question from you? Any question, please? Is it okay? So, okay, I will share with you some document, and you can use. But if you, this link is very helpful. I am sharing with you. You can open your system on your mobile. Also, you can use on your mobile. You can open, you can work on it. I am sharing the link in your chat box. This is the link for live.sympy.org. All the statements which I discuss here, you can execute on your mobile also. Okay. Only for SymPy library, which deals with the symbolic mathematics using Python. And the same library you can easily import in Python programming. Okay. Just you need to import this SymPy. So there is no difference in the syntax. Just I'll provide this link for your use. And also, if you need the documentation of this one, okay, you can easily download the documentation to understand the syntax. Once again, I am sharing with you. You can see this is the SymPy, live SymPy, and from this place, you can download, and here you can see documentation. When you will click on the documentation, and also there will be option to download the documentation. Just 1 minute, from where you can download. Modules. Yes, these are the modules which are available in Python module index. Okay, you can see there are different modules. List is there. SymPy.abc we use. You can use also SymPy.algebras, SymPy.assumption. Okay, SymPy.calculus is deals only for calculus. Like sometimes you need to use for Euler, SymPy.calculus Euler. Okay, and if you need more detail about this, you can open and see. There are several examples will be there, and you can find out how you can use for your programming. Okay, it is very quite simple to find. Okay, so you can see all these at this place. Just 1 minute. Okay, so all these are deals with the different purpose. Also, if you are working on the functions, special function, discrete transformations, convolutions, geometry, crypto, traversals, simplify, symbols, we use this for symbol, simplify function is there. So there are different modules, and all these modules deal with the different purpose. You can see simpy.geometry.carve. Okay, you can open it and you can see the examples how we can use. Then we have ellipse, entity, line, all the modules which deals with the mathematical integration are available here for matrix. Okay, immutable matrices, sparse matrices, many examples are there. So this is the complete list, okay, for SymPy. Also, if someone want to work on quantum mechanics and physical problems are there, so you can use this SymPy.physics for quantum mechanics, for control, many things are there. Okay, so here are the list of, and any tool which is helping for your work, you can easily use this module and import in the SymPy, and then you can use. Okay, so this is very quite simple to use, but need some time to understand these modules, how we can use. Okay, so you can see the complete list, and all these are not simple to present in the few hours. Need a lot of time to present all these things, but all these are these modules are managed in such a manner that if one is working on differential equation, then we import only that particular module. If one is working on the geometry, then we import only that particular module. Okay, so the thing is, once we need to understand how we can import the module and how we can use, only this thing is important. Rest all the examples are available, and the environment is very friendly. Documentation for SymPy is available, examples are there, and this is very helpful for mathematicians, engineers, scientists, and this is going to take place of Matlab and Mathematica, and also Maple software, because this is a very open software and many things are going to update in very speedily. If more question, please let me know. I am separately sharing the link so that all this will be very helpful. And if you want to ask any question, please feel free. So I have provided all the links, and all these links will be very helpful. If you want to download Anaconda, link for Anaconda is also there. Okay. So one thing is also important, which I let you explain, and all these we will discuss in the coming days. See, this is the Anaconda. So we can use also Jupyter Notebook. We can use Jupyter Notebook or Jupyter Lab for the same purpose. When you will click on this launch, this will be launched, and yeah. So any file you can open at this place and we can work on it. and also we can use Jupyter Lab. Yes. So Jupyter Lab we can also use, and we can open a new file and then we can work on it. Okay. Yes, we can write here statement and we can work on it. All the things which we work by using Spider, we can use at this place also. So this part will be discussed in the coming session. At the same time, on Saturday, we will discuss about this module, Jupyter Lab, how we can use Jupyter Lab for mathematically computing, and this will take less time because the thing is that which we use in Spider or symbolic tool can be easily used in Jupyter Lab. Okay, so today this is enough, and if you want to ask any question, please feel free. You can unmute. If any question, please let me know. Or you can write in the chat box. Why all of you are silent? Samuel, why are you silent? Sunday Simon. Yes.
We're not allowed to talk. It's just now that you unmute me because it was all blocked. Thank you.
Please repeat your question. I don't get your question complete.
No, I said we were all blocked.
Can you type your question in the chat box? Please put your question in the chat box. The most important thing about this Python is open source, and sometimes we have problem to purchase software like Matlab, Mathematica, Maple, because these are very highly costly. Yeah, Samuel asking, yes, in the coming Saturday, we will continue because this is the just beginning, and all the basics which we can use for mathematically, or yeah, same time will be same, and this will be held through Zoom meeting, and I will provide you the link. Okay, so you can easily join, and we will cover different type of topics. But the thing is that you also have to start. Okay, if you will start, so we will develop a community to use Python for scientific calculation, for mathematical calculations, and then after like numerical mathematical problems are there, automation techniques are there, Okay. Then we have machine learning, deep learning, data science. We can, yes, we can use for mathematical modeling. We can use for mathematical modeling also, which are related to first order derivative or partially one variable, two variable, three variable, any kind of system of differential equations, any type of mathematical modeling, we can use Python also. And the most important thing is that it is open and free available. Yeah, for epidemiology also we can use, because yes, also we can use right now I am working for artificial neural network. We are using to find out the solutions of differential equations and fractional differential equations by using Python, and also I am using Matlab. So the thing is that we can use Python software for any kind of calculations. Okay, admin did not. No, you all are unmuted. Just 1 minute. Yes, you can unmute. Sunday, you can unmute. Sunday Simon. I mean, we were all muted by the admin. No, you are not muted. You can unmute. Check it. You can unmute. No problem from his side.
Hello, sir. Can you hear me?
Yeah, I can hear you.
Okay, thank you very much for the lesson. Actually, I'm new. I didn't know anything about Python before today. Thank you for introducing me to it. Actually, the one that is coming up on is it in August? I think that is when we'll learn everything about Python. Just the same way we gained from Matlab workshop last time. So thank you very much for your commitment, all these things. And by God's grace, in the near future, you will see the fruit of your labor by His grace. Thank you,
Yes,
sir.
thank you. Thank you very much. So we will continue. And actually, we want to develop a community where we can help each other. And we are doing in this direction also. This is a very emerging tool for mathematicians, scientists, engineers, because many times I also myself face many problems during my work and also still now. Matlab is not easy to purchase because the license provided by the company is for 1 year, and after 1 year we have to renew, and there are a lot of updates are there. Okay, so in institute if we have, then it is easy, but this if we don't have Matlab, it means we are still we can work, but the open software is very helpful. And all the things which we are doing in Matlab for mathematically, yes, this is not free. August schedule, not free. Yeah, sorry, this is not free. Why? Because the thing is that foundation is required some funds, because all the things are managed. There is no any source for the fund of this foundation. So sometimes we have to organize paying paid events. Okay, that is a different event, but basic fundamentals will be continue, which will be held on every Saturday. and there will be these event will be held in two different ways. One is on the Zoom meeting, and other will be also live streaming is there. As we can do much help for you. But when we organize the event like this, which will be a regular event, so all these are managed by my own self, and these will be free. But when we have organized through MTTF, this is also the platform of MTTF. Then when we have out resources, like you can say in the August event, there are several speakers we invited from different institute. So we have to pay them for their lecture. So the honorariums which we give them, we have to, in that case, charge, because we don't have fund. So that's why this is a paid event. But if I will try to continue all these sessions, once basic fundamentals will be clear, then you can use for your own work. Okay, this is very huge. Yes, you can use Jupyter and Spider. Actually, the thing is that what is Anaconda? What is Anaconda? Anaconda provide us a different type of editors. Okay, all like Jupyter, Spider, and others are, these are the editors. The different the purpose behind these, like PyCharm is also editor, which is used for Python. So these editors provide us environment like Matlab, environment like Mathematica, environment like other software. So when we use these environments, we can easily control all these things. Okay, and all the commands which we are using for Spider, which we are using for Jupyter, which we are using for PyCharm, we can directly use in Python also. Okay, but Anaconda is very helpful. All the things are available in the unique platform, and in the coming session, I will let you know how you can install. After installation, you need to install some libraries, and when you will install the libraries, only after that you will be able to use. As you see that I was using SymPy. Okay, SymPy is a library for symbolic mathematics, but that was already installed in Anaconda. That's why it was quietly I was using. Okay, when you will install the Anaconda, then you need also install the libraries. So in the coming session, I will let you know how you can install these libraries, because there are thousands of libraries for different tasks. Okay, like in the Matlab, there are different tools are available. Tool for optimization technique, for machine learning, deep learning, for data science, for statistical, for symbolic mathematics. There are different tools are in the Matlab. In the same way, in Python, we have different libraries, and all these libraries work for different tasks. Okay, so when we started to work by using Python, which library we need for our work? So that library, yeah, NumPy is also library. NumPy is also one library which is deals with the numbers. Okay, so different libraries are available, and I will let you know how we can install these libraries in Anaconda, and then you can import these libraries in SymPy. You can import in PyCharm, in other modules. Okay, so this is very helpful, and I hope I would like to ask you also to connect more people so that last time actually the thing is that there are about 75 people registered, but 2 times I have to cancel the meeting due to some technical issues with me, and that's why I have to fix the Saturday, because Saturday I have full day to work on it, and in the working days it was very quite hard to manage all these things, and when I would going to start, there was a technical issue and I was not able to start at the right time. So please excuse me for this inconvenience, but I have fixed the time. On every Saturday we will be available here, and the session for Python will be continued. Okay, and if you have any kind of suggestion, please let me know. I will be very happy. Yeah, the question is how many more Saturdays, sir? Yeah, we will continue about this will be continued for 1 year at least, because this is very wide area, very wide. So in every Saturday, about I will take I will try to continue for 1 year. Okay, so all the things which deals with mathematics, I will try to cover. And the thing is that also we need support from you. Okay, the support is to connect to the audience, and if the recording is needed, live streaming is there and the recording will be available for your future use. And also we try to provide some content in the coming days. We are managing all these things myself, and workshops and training programs have different benefit, because in that case we cover a particular area and all the things, because there are several speakers and they have different ideas, different skills. So this type of training programs are also beneficial for our community. Okay, so thank you very much for your presence in this session, and we meet in the next session, which will be held on Saturday at the same time. And if there is any time is required to change, I will let you know. You will get the information okay, through email address is there, WhatsApp group is there, WhatsApp group for numerical methods. I think all of you are in the group. Now, thank you very much for joining this meeting. If any more question, you can WhatsApp me. Okay, or you have email address also, you can email. No, for this there is no feedback is required, because we are gathering here for exchanging the ideas to help. For this we need not require any feedback, but if you feel we will consider in the coming session, please let me know if you think that feedback is required. So in the coming session on Saturday, I will provide you the feedback form also, if you think, and if you think that not required, then we can exempt. Sometimes we will provide the feedback also, so that if you have any question or you want to submit, this will motivate. Okay, so it's nice talk with you, and have a nice day. Thank you very much to be part of this session.
Thank you, sir.
Thank you. Now it is time to leave the meeting.